a huge reduction of the code size. And mostly it's high level. I bring here the examples of OpenCL versus SQL. So if someone doesn't know, SQL is a quite new standard which is built on top of OpenCL. And I think it's a good comparison since they provide a very high level interface. Writing certain applications or libraries on top of SQL is much easier than just using the OpenCL directly. Yet it is still possible to do some low level things if you access a route object directly.
Too bad the CodePlay guys aren't here today.
Yes, I don't know if they joined today, but I think they would like their friends. And also we worked together in the past, so it's not a perfect standard, but I think SQL has some. It's definitely an improvement towards on top of OpenCL. So with the namespaces, this is actually a very simple change. So in HiHat, we have function prefixes, which are supposed to notify the user in which module this function belongs. So we have functions in the user layer, in the common layer, which is, if I understand correctly, more low-level functions which are used by HiHat directly and are not used by HiHat users. There are functions for graph, functions which can create values, functions considered experimental. This is generally not maybe very user-friendly, so we want to, of course, in C++, we want to use namespaces directly. At the moment, we just use one namespace and perhaps one for experimental, just to notify users that there are some beta features. And there's also the question to the community if they feel that using nested namespaces would make it easier to understand the different modules which are available in HiHat. Of course, at the moment, it seems to me that implementing some or wrapping some functions, such as the one which belong to the HHC, which is the common layer, may not be even necessary, since if those functions are very low level, if they are supposed to be used most of the time only inside in HiHat functions, then it may not make sense to import them into a user-friendly high-level C++ API.
Do you want to comment on that now or later?
Yes, please comment.
There are two intentions for the distinction between the user layer and common layer APIs. One is, as you say, that it's a simpler building block. The other is that, the corollary to that is for ease of use, that a user layer may do something that's more abstract and that requires some extra work to figure things out, such that, so for example, you could say, move from here to there, and I'm not going to tell you how, you figure it out, right? And you meaning the implementation underneath the user layer. The common layer APIs are there for performance. The essential distinction between the user layer and common layer API is that while the user layer may look some stuff up, track some extra detail, figure some things out, the common layer ones are there really for performance, where the client of the APIs knows exactly what they want to do and want to do it with absolutely minimal performance overhead. And so there are cases where it's not just a lower level detail that's gotten encapsulated in a user layer thing, but because for these kinds of frameworks, doing performance is such a primary goal, there are cases where you do in fact want to, if you know it, you want to do it directly.
I see. So perhaps I'm simply biased because I'm looking mostly as a user, a potential user of HiHat. Maybe that's why I look at it into this way. But yeah, I think I understand what you mean here. So perhaps what we might go as for the final solution would be to have some partial cover of the total API, and also the ability to always, this is what we want to achieve, is the ability to always connect with the C API. So something that if you really want to go for the performance solution, you can always access whatever objects are used and implement something directly with the low-level common layer API.
I think it's, as a starting place, I support starting with the user layer and extending to the common layer as you see fit. Makes sense.
I think I also consider this approach to be the best in our situation. I don't think we don't want to really start with the full project, just build it incrementally. Maybe it's easier to implement this. So as an example, what we're trying to achieve is, this is actually the first line from an example we started working on. Mostly, this is actually a function to register user task, as the name suggests. So we took all of those corresponding C functions and tried to encapsulate it into C++ objects to make it maybe easier for user to process. So for the moment, we get rid of the HiHat check and macro for error processing. I will also discuss error handling slightly later. We introduced enum classes, at least for the moment, but this is also a part of discussion between us and the HiHat developers. We also introduced additional classes like blob to cover static and dynamic blob, mostly to increase the readability of the code. Our objective here was to go from a function which has several different parameters, and it requires a lot of documentation to actually understand from the user perspective how to use this function. So we want to minimize the impact of that. And in this example, task handle is the wrapper around the HiHat C task handle. And we want to keep the wrappers possibly rather simple. So just wrap the C object and always provide the ability to get it directly. And this also connects from what we discussed just before, is that we want to leave the ability that even if we don't cover everything, or we just aim for the most common usage cases, we want to leave the possibility to always access objects and implement something directly. And I think this idea is very similar to what SQL is doing, almost not for every object, but very often leaving you the ability to go directly for an OpenCLC object. And also what we're doing so far is when we're trying to reduce the number of parameters, trying to reduce perhaps the not so common parameters. I think what might be the best from user perspective is to optimize it in the sense that provide, for example, constructors for task handle or builder or factory functions for cases which are most common. So we still leave the option to always use the full C API where you can specify everything, but we want to make it maybe not minimal, but slightly smaller, and simply target those cases which are most common for users. And here I think is the most important part is the Graph API, and I will show it directly on the code because simply it won't fit on most of the slides. So on the left we see CUDA example of HiHat built on top of CUDA graphs. It was presented and created by CJ, if I correctly.
Wojtek, actually.
Wojtek, yes, and sorry. So as you can see, this code is pretty large, of course, mostly because of comments, but this code is actually creating a very simple graph which consists of 4 nodes and an additional node which is subgraph with a very simple data flow. There's only one diamond pattern here, and most of the data flow is rather simple. But what strikes us, what we noticed with Tal is that even creating such a very small and static graph requires a lot of code to implement that. So of course you need to predefine everything because HiHat C functions they don't return the value. They always have to take pointer because of error handling. Later you first have to define the nodes, create them with corresponding descriptor, and then add those nodes to graph. And in the next step, only the connection between nodes is created. So what we didn't like very much about this particular scenario, or maybe we thought it's not the easiest for users when you have to create static graph, is that the node creation and edge creation is completely separated. And just by looking at this code, without additional comment in the header specifying you how this graph actually looks, it takes a lot of time to read this and understand what are the data dependencies in this graph. How does it actually look? How it's going to be executed? So we tried to go for an interface which would allow the user or any person trying to read and understand this code to immediately have an idea how this is created. So on the right, we show our proposed and working sample, which is supposed to provide exactly the same implementation as the sample of the left, but with a more high-level and abstract C++ interface. So we leave the option to always create something dynamically, similar to the C API, because of course there will be situation where a graph may be created dynamically, or it might happen that the graph is so complex that it's easier to do it this way. But what we really want to achieve is to have a situation which we present below, slightly below, is to be able to create a graph using operator overloading in a way which is already explicitly states data dependencies. So here we use the ampersand operator to indicate the actual edge between two nodes, and we use logical OR operator, binary OR operator to signify that certain nodes or certain paths in the graph are executed concurrently. So this is our first proposal we come with. We are not entirely certain at the moment that this is actually the operators which are the most obvious, but I think what this implementation brings compared to the C implementation is that it's quite immediate to know that first graph with this specific descriptor is immediately followed by another one, and there is nothing between them, and they are a strict flow dependency in the graph. And I think we think that will be the most important contribution from on the C++ side, since this is one of the most important challenges for the user to really create a HiHat program or from a library perspective, which creates graphs, and those graphs have to be the creation has to be safe in this sense that we want to minimize a likelihood of making any mistake. Also, additional feature that's also coming directly from wrapping is that we have this structurals in C++, so we can move part of the cleaning process directly to the object. So actually the code sample, the C code sample has a lot of direct calls to destroy functions. We can also wrap it inside an object and again minimize the code bloat. Also later, when we create a graph, there's also the graph instantiations invocation. Here also we think that just by using the overloading the function call operator, we can also make it simpler and just more user-friendly. So instead of providing directly functions, as long as we believe the operators we overload are their meaning is kind of obvious to the user, we can make it much easier to understand. But of course, we hope that our choice of operator overloads here is obvious to users. So I'll go back to presentations. So as I said, we want to keep the API in a way that you can still create graphs dynamically, but we want to focus on getting an API which allows you to write graphs in a way that the actual code creating nodes and edges is kind of obvious, so that you don't need very expressive and long comments detailing how this graph actually is supposed to look like. Another feature we already discussed with CJ and Wojtek is that we would there are several enums used as a configuration flags in the C API. We could transport them directly to C interface and use enum class to benefit from the implicit scope. This makes the code slightly more verbose, but it's perhaps easier to see to which enum type does the value correspond. But we also get the initial feedback that putting an enum type directly interface make it less robust and slightly more verbose. So I think it's something that we can decide together. We are not forcing this decision. So it's all about finding an API which is the most user friendly for the moment. But
do you want to pause for any discussion on that?
Yes, please.
That's more of a question to everyone else. Are there more pros and cons that people see with this? I think Wojtek, you had some inputs. We shared some feedback. Maybe others have some comments.
So our idea here was mostly to enforce static type checking, but yeah, I know that where these are the CJ and Wojtek raised the concerns. So perhaps if someone else believes that it's not a good choice in general to put enum types in APIs.
Got a quiet crowd today. I wrote the thing, but Wojtek, I don't know whether you want to jump in and comment on the some of the concerns we had for this, or you want me to, whatever.
Sure, no problem. I can jump in. The issue I was pointing out is that depending on the compiler switches, enums might have different sizes, and while that usually won't blow up in function arguments such as this case, because on most platforms there will be still past 64 bits regardless. It may blow up in things like structures if we make structures part of the interface, if we have some structures and then the size of the structure and the offsets will be different. If there's sorts of different things that can break just because enum does not have a predefined storage size. And this was my primary objection. The problem also is that over time the size of the enum can grow because you add things or you decide that the enum represents bit fields, in which case you can easily grow to a larger integer size. And with a subsequent version of the library, you would be expecting a larger type than what you will get passed from the client that was compiled against an older version of the library. And again, on many platforms that won't be a problem, but it's just a matter of many things playing together nicely, and that makes me anxious. I think because enums end up being used in places where you have to have integer arguments, such as when enum values represent bit fields. I mean, specific bits in a potential mask, and you end up using the values, combined with logical with bit operations in an integer form. I think it's not a huge jump to just always use enums in integer form as argument and just point to documentation to the possible values as a specific enum or enum class.
Yeah, I think I understand your concerns and I think they're valid. Although I wonder how much will be a problem if we go for a C++ API, which is a header-only library. And if it's something that, because I'm not intending to change in any way HiHat C API.
Right, yeah, so there are APIs in HiHat that take structs or structure pointers. And the same applies regardless of whether the wrappers would be a header-only library or an actual library. So depending on, I mean, 99% of the cases, people don't use weird compiler options like short enums, for example. But then they might, and HiHat might expect a different layout of struct, and the C++ wrappers, the header-only library would provide a different layout of the struct to HiHat.
I understand. So, okay, so understand it in terms of compiler options and the possibility how it will change over time. It's the safest option to stick with a signed integer type.
Well,
it kind of makes it harder to shoot yourself in the foot, I guess.
In my mind, because I haven't thought that through, though, I wonder if you have a valid point, Martin, that if it's a header-only library, so there are two questions here, I think. One is, should the C++ API force the function parameters to use enums wherever it makes sense? For example, potentially not in cases where you're orienting together a bunch of flags, but in cases where it's, you want things to be typed, and it would make sense to do so. So one thing is doing that in the C++ API, which is header only. Second thing is whether we should change the C APIs to do that as well, and that the determinations and outcomes could be different. We want to be inspired by any ideas people come up with for changing the C API where appropriate, and one outcome of this is to not necessarily change the C API, but to go ahead and use enums wherever it makes sense in the C++ thing, because it's header only and is, I think, potentially then not subject to the concerns that you were raising, that you just articulated, Wojtek.
So I think that our idea from the beginning is to, we are very happy to provide feedback from the C API and to maybe suggest improvements or very simple fixes such as the recently with the char pointers. But in general, we want to build on top of C API and just we don't want to sacrifice anything in the C API to achieve any kind of any improvement in code readability and user friendliness. So in general, we want to build on top of that, and whatever we propose, 99% of the time will only influence a C API.
Okay. Well, we do want to be open to change elsewhere too. But before we move on, I know we have a number of other people that are experts in C++. Any other feedbacks from other folks on this? Michael?
I actually have a question. Let me just ask you a question. How do enum classes in C++ compose with creating bit masks by ORing different enum values together? They're not implicitly converted to integer types, so does it even work when you OR different enum class values together?
I think we can always provide implicit conversion, right, operator?
I guess so, yeah.
I guess we.
Do you have to wrap every instance of an enum with a conversion operator and then OR them together? That's a lot of typing.
I absolutely agree. That would be horrible. I agree with that. No, I think we can. I think we done in the past that we can simply provide implicit conversion operator inside the enum class. But I think so. If I'm wrong, please correct me. But that's what my vision of that.
Okay.
But I may be wrong. But if that's something that we can definitely, I have to check later. And I will go. Yeah, we'll later let you know what was the result. But I I will just have to verify to be completely certain.
Cool. Thanks.
So should we move forward?
Sounds good.
Okay. So I think, but what I expected maybe the biggest issue here is the error handling. So in the C API, most of the time, if not always, HiHat functions will return error code, and there is very convenient macro which allows you to automatically check and stop the program execution or print an error message depending on the outcome of the function. This kind of doesn't connect with our way of always returning some type, not having to predefine it. So we proposed 3 ways. One of them is we could always return error codes to basically duplicate the behavior of the API, but that doesn't always work such in cases like, for example, for constructors, we would need something like a factory method. We could go for exceptions, and here I think that every function of C++ library would have to throw just to be consistent and to basically wrap everything you do in a try-catch clause. It would also be possible to just return a value in error codes, but it has to be implemented manually, as I see in the moment, since there is no standard support for anything like that in C++. And that is mostly the the point that we really want to see the feedback. We already discussed it with CJ and Wojtek, and we know that as long as we go for the header-only library, then we should be safe to use exceptions. And also, personally, I think both me and Tal would also prefer the exception version, but the version of just handling all the errors with exceptions. But I would like to ask if there are other people in the discussion who have their opinion and want to raise some objections.
I would just mention that adding exceptions to libraries often causes a lot of headaches later. And adding exceptions to this interface is tantamount to deciding that you basically never want it to be running in a CUDA thread, for example. So if you imagine that this interface is only ever going to be run on the CPU host, exceptions are perhaps tolerable. But if you ever want to have some kind of device-side interface, you really don't want exceptions.
Thanks for the comment. Yes, I absolutely agree with that. However, I think so far we've only thinking from the host side perspective. But CJ, do you have a comment on that?
I get itchy when we say, "Oh, we would never want to do that." I've been trained to think very carefully. I think that there are cases where in the future we may wish to have, if we go in the direction of being able to facilitate on a GPU. So I'm just totally brainstorming here. If we were to try and go in the direction of saying, hey, let's make it easier to create persistent kernels and to manage graphs from within the GPU in itself and have a little runtime lit over there, it's probably a thinner, lighter version to be running on a GPU. While that's a stretch, it's not totally inconceivable, and that's a hard problem anyway in doing, to be able to have management of code from the GPU side, from a less capable computational unit. And if we're going to do that, having some software abstractions to help with that are probably useful. So my feedback, I think, just going off the gut, would be to architect it in a way that gives you the option. And I don't know how you would do that if you started going down the route of exceptions. Maybe there's a great way to do it, but I'm not sure if you started baking that into all the interfaces, how you would do that. And maybe you could have, a couple different C++ interfaces, one that would use the exceptions approach and one not, but then you have to ask, well, how compatible are those? And if you're going to change which of those you're going to use in the middle of it, how disruptive is that going to be? So I would urge a bit of caution before we jump.
Okay, I understand. This is exactly what I wanted to hear, and I think it's a very serious concern. In general, again, my gut feeling would be to definitely don't go into an option of having multiple interfaces supporting multiple features. So I think it's maybe better if we sacrifice something and go maybe with a less annoying, with a more annoying solution, such as dealing with error codes, but something that is potentially have more perspective for the future usage.
I think it's worthy of debate, but
question.
Yes.
So this discussion was mostly about the errors and exceptions concerned with the C++ layer on top of HiHat. But what about the user functions that are actually executed as the graph nodes? Do we need to impose some mechanism for how they report errors as well here?
I think that's the primary responsibility in terms of HiHat's direct C API. I actually don't know how what kind of restriction does HiHat itself puts on user functions.
Okay.
We want to avoid putting such restrictions on. You want to say more about your concern, Dmitry?
No, I'm just trying to clarify just the full picture.
No, so far we've only been discussing just the API, let's say the error handling between HiHat runtime and the user code, which creates graphs and schedules work.
So it's totally, I think it's obvious to all of us that it's totally necessary that in addition to some fixed functionality, that you totally need to be able to provide user-defined functions for all relevant targets and a way to register and access those.
Yeah, absolutely.
But do we assume all user-defined functions to be C?
To be what?
To be written in C? Or, like, for example, if there is a user-defined function in C++ and it throws exception?
Ah, now I get you. There's no presumption whatsoever. It's kind of a key thing that there's no presumption about. There's a desire for there to be no restrictions on what the implementation language is. There was an expectation that we make things work through a C API in the implementation, and I think you're getting it. Well, then with respect to things like exceptions, how do you make some of those C++ function invocation and error handling mechanisms work through a C API, even if you were to wrap it again in C++?
Yeah.
Is that the nature of your question? Yeah. And I don't know the answer.
Okay.
And if the answer to that was we couldn't use a C API for that, then I think it is an option. Then the C++ would no longer be just a wrapper, and we could have an alternate implement, an extended API specifically for C++ function implications, or if God forbid, if we needed one for Fortran and Python and Ruby and one for each, because that was really necessary, we could go there. It would be, I think, want to understand where and what benefits that would bring and why that's really necessary. It'd be good to sketch that out if there's clarity somebody has.
Okay. I mean, like, for example, if the node implements a custom memory allocator, so it's a user-defined function, and it fails to allocate memory, it's just what exactly is supposed to do within the HiHat framework?
I don't have an answer to that. I don't know whether somebody else does.
Me either for the moment. But again, this is something that interesting, but this allocator would still have to communicate in some way with the C API. So it's a question whether C API could handle such situation.
Right.
Okay, just it would be great if, Dimitri, for example, you want to pose something that that is a C++ function that is trying to use exceptions, and look at whether and how that can be plumbed through the C API that we have without loss of functionality and generality. And if it can't, figure out, come up with a clear articulation of, well, what do we actually need, and what would a natively C++ interface then look like to complement the C API that we have now. Are you willing to take a crack at that in a specific example with your allocator?
Well, I'll think about it. So, but yeah, I'll just trying to clarify some things. Yeah.
Yeah, that's a great question.
Sorry for interruption.
No,
that's great. That's why we're meeting. So I just captured that you'll consider it and maybe offer an example. You didn't promise to.
Yeah, I'll think about it. I'll try to see if I can come up with something visible here. Yeah.
Great.
Are there any more questions related to error handling? Okay, so I think we can move forward. So I think the last important part is we also noticed some minor suggestion. So as I said before, there's a lot of C API functions related actually to cleaning and destroying certain resources. I think it's all can be easily wrapped inside the wrappers to just use inside the structure and make it slightly more safe. Also, but I think we might benefit from having the ability to fire cleanup user-defined cleanup functions. This is partially motivated by the example we had, but in general, it make it easier to clean, for example, memory allocated on the host side after the work is done, and to make the interface slightly more asynchronous, so that the user doesn't have to explicitly specify synchronization, but maybe it would be safer if generally the chain of destruction, when, for example, something goes out of scope or some large object is deleted, would actually make all the cleaning in the right order. So I think this is something we also want to consider for the interface. And in general, so far we found, I believe, 5 important questions that we need to answer. We have, let's say, our answer at least partially to some of them, but I'm very happy that at least we got very important and very useful feedback to some of those questions, especially for ways such as actually the first question of handling errors. Also, we cleared up a lot over the enums. In general, questions such as header-only implementation in the library, I think we can be very flexible. Maybe header-only version makes it much easier to deploy and use by users. But from my perspective, really the important part, from a user perspective of someone using HiHat graphs, it is really important to provide an interface which make it easy to create a readable and clean code for creating graphs. And also the question 5, I think our at least my view at the moment is that we want to build incrementally, cover larger and larger portions of the interface, and I don't at the moment I don't expect that in the end will cover everything of this API, because perhaps there is something that will never be used, and maybe we shouldn't spend resources on implementing that. But in general, having a proper feedback from the community, I think we could move into implementing and working with initial features, something that we already know is useful. It will be used by the users, depending on usage scenarios that we consider. So I would like to thank you everyone for the feedback, and if you have any questions or comments or any additional feedbacks and objections, also please raise them, and we'll be very happy to consider and discuss it.
Do you, out of the first one regarding exceptions, do you also want to take that back into some consideration, and does any of this discussion affect your thinking on that one?
Yeah, absolutely. We have to think about it, we have to discuss it with Tal, but in general, I think we have very valid reasons to now go with exceptions. I still don't like the solution of just going plain C style error code, so we have to think if we could produce a usable and nice solution which is an alternative to both of them. Perhaps we can't. I hope we can produce something usable, but this is something that we have to work on. But definitely we understand the concerns going with exceptions.
Okay. Some other feedback? I just saved the notes I took, so if folks have other comments or want to edit, I think you can all edit the notes. If you have anything else there.
Yeah, anyone who has an edit login can edit the notes. I still haven't found a way to download all the attendees, CJ, but I'll keep looking and see if I can find a way to do that.
Okay. You can just keep typing. Works. Okay, well, we really thank you for Martin for presenting this and working this up. You put a lot of work into considering these. I think it's cool being able to do this. There's some other folks I think that would be good to get eyes on this with, like the folks from CodePlay and Matthias Nowak had looked at doing something like this in C++ as well. So I'll reach out to those folks in CCU too to see if we can get some more input on it. But it's good work.
Yeah, that would be great. I think they have huge experience in building such interface, and so I'll be very grateful for any additional pair of eyes who can take a look at that and spot our mistakes and present better solutions.
And I think it's your intention to work towards not just sort of doing a pen and paper experiment like this, but actually to do an initial implementation of the most common cases and sort of work through some solid examples with it, right?
So I think we started to work on some prototypes, but I cannot promise at the moment that we'll be able to deliver something that is, let's say, of a high quality and working with huge parts of the API. But definitely we've been using some prototypes so far, and we want to develop it further.
Mm-hmm. Okay. Great. Any other comments? Super. Well, thank you very much for that again. And please chime in. Feel free to share this with anybody else that you think could be interested in it, and we'll go from there.
Thank you for all the feedback and questions and comments.
Thanks, folks. Have a good one.